let's start. All right, well, welcome. And yes, there were a lot of operator talks this week so far, and there's probably a few more tucked into the end of today. So I'm really pleased that you all came. So keep coming in. If you have an empty seat next to you, raise your hand and meet somebody new. So please keep coming in the back. So the name of this talk is the state of operators, hubs, frameworks, SDKs, and beyond, which gives me a very open-ended questioning series that I can ask these people. If you don't know me, my name is Diane Mueller. I'm the Director of Community Development for Red Hat's cloud platform, which means lots of things, but one of the things that's near and dear to my heart that I'm working closely with behind the scenes is something called operatorhub.io, and if you haven't visited it, please do, and we'll talk a little bit about that and other hubs today as well. So Kubernetes developers and service providers and hosting providers have really embraced the operator pattern. And since CoreOS, was it 2016, sort of put out the first blog post about the operator pattern, there's sort of been an explosion of people embracing that pattern. And I say pattern specifically because there are lots of ways to do it, sort of like when you're sewing, lots of ways to make different dresses. And one of the things that we're trying really to tease out in this conversation is what is the future of operators, where is it going, and what are all these frameworks kind of thing. And so there are many production-ready operators now in Operator Hub, in other places, in GitHub repos. There are many operators that we've been seeing rise up inside of enterprises that you guys probably, if you're a vendor, will never see because people are building these custom ones. But there's a real enthusiasm, shall we say. And the operators, how many of you know what an operator is? Yay, so I don't have to define it, thank you. And I'm sure people will have their interpretations as well. But they really allow developers to create some really powerful tools that can be used on any infrastructure, on any Kubernetes infrastructure, wherever Kubernetes is installed. And so though I may be at Red Hat, there's a reason why I'm wearing a neutral colored hat today. I really have a great enthusiasm for the ability to discover and find operators of any ilk that can be run on any Kubernetes platform. So I don't want to talk that much today. I want to ask some questions. We have a really interesting, what I tried to do today was gather people who have built operators, people who are helping to build the operator frameworks, at least one of them or two of them, and to get a little history going here. So I'm going to ask each of the panelists to introduce yourself, starting with Andre here, and a little bit about your background and your role in building operators and where you're at. And Andre, Tost comes from IBM. Go for it.
Can you hear me? Yeah. So I'm Andre, I'm from IBM. I'm part of a central team that helps essentially bringing our entire software portfolio to containers, primarily targeting OpenShift. So we're working with about 100 different distinct products and offerings. As part of that, we're introducing operators as kind of the standard operational model for end-to-end lifecycle management of all that software portfolio. So my team specifically works on setting standards, conventions, best practices, guidelines, so that all the teams kind of go do this in a similar kind of fashion. I'm working very closely with the operator framework team, very active in that community. We try to do all of the operator work in the open. Where we stand right now is we have a handful of them built. So we have some early adopters. We have many more to come. I keep saying that next year we'll be bringing a wave of new operators into the community, basically representing, like I said, the entire software portfolio that we have.
And so from Lightbend.
Yeah, my name's James. I work for Lightbend, which is the company behind Scala, Akka, Play Framework, Lagom Framework. And my role is architect of open source. So in that role, I kind of work across a lot of our software and with a lot of cross-cutting concerns, particularly researching new things and understanding what direction we should go. So operators has been a big part of the work that I've been doing over the past year or so in understanding how we can utilise operators to make the experience of deploying applications built using our software easier for our users and our customers. I also spent a lot of time writing operators myself. Another hat that I wear is tech lead of a serverless framework called Cloud State, and that's a lot of operators there. So, and pushing a lot of what we think we can do. So
yeah, and I'm going to thank James because he's filling in for Kiki Carter, who couldn't come to Kubernetes. So thank you for showing up.
No worries.
This should work. Hi, my name is Sonam. I'm a product manager at Google Cloud. And my team works on a product which essentially intends to make the entire surface of GCP Kubernetes-like. So as I was saying just a few seconds ago, to this group of people, you can basically install config connector inside any Kubernetes cluster. And then all you need to do is kubectl apply config.yaml, and now you can manage all your GCP resources as if they are native Kubernetes resources.
And I'm Jeff McCormick, work at Red Hat in the Operator SDK team. I came to Red Hat from Crunchy Data, where I wrote the Postgres operator. Started that 3 years ago, kind of at the very early stages of when operators came about. So it's definitely interesting to see the level of interest and the amount of tooling that's come about right now.
Yeah, perfect. Yeah, but now you see my desktop. I'm just going to go. I can't even find the opening slide, so this is a blatant advertisement for operatorhub.io. So I'm going to start by reading a definition. The original definition I got off a CoreOS website, which is still up and running, is that an operator is an application-specific controller that extends the Kubernetes API to create, configure, and manage instances of complex stateful applications on behalf of a Kubernetes user. And the reason I really like having Jeff here is that he's been doing operators since the pattern sort of first emerged. And I'm wondering, starting with Jeff, if you think that definition still holds. And there's a lot of debate. If anyone's on any of those threads, I apologize, but go ahead.
Yeah, I think so. I know whenever I started this, my focus was around, how do I manage a database on a platform like Kubernetes? So it was kind of infrastructure, foundational things people would need to build higher level applications. And 2 years heads down building that was kind of my thought process, is that, well, this operators concept is really for big infrastructural type things that application developers might need. I think now my attitude is that I fully expect operators and that concept really to move into higher level application spaces. So like manufacturing apps or airline reservation systems. I think the same patterns apply, but I think they move up a level, you might say, into end user applications. And to me, that's really exciting. And I think the frameworks and tooling required for that is real exciting to see. Maybe higher level abstractions as opposed to really, really low level things that we've had to concern ourselves with. So I see operators as moving up the stack, you might say, where somebody just wants to build a manufacturing app as an example, or an accounting app. I mean, they don't necessarily need to have to know the lowest level details like we used to 2 years ago. So I see operators moving kind of in that application space.
Anyone else have any debate about the definition or changing it or anything like that? Or you want to add to that? Okay, cool, good. Look at that, consensus. I'm a consensus builder, not an instigator. So the other thing that we hear a lot about operators is, and operator life cycles and management, is their ability to help with the day two stuff. So going beyond the simple install of your application or your service or your database or whatever it is that you've built. And I'm wondering, how do you see, for me, and I'm opinionated, that is one of the bigger benefits of the operator pattern. And I know Sonam is very interested in this second stage, the second part of this. And I'm wondering, from Google's point of view, why should you care about this in terms of, like, say, your DevOps pipeline?
So the way we look at, at KRM in general is that almost every industry went through a stage of evolution. So if you think about the energy industry, we had steam as a competing standard for transmitting energy, but now we all agree that electricity is the right method. And then there are subsequent industries lower from that are now adopting it. So you're seeing this entire, electric car revolution that is happening right now. The same is true for Kubernetes. Once you agree that KRM is the right language to use across your hybrid cloud environment, that makes a big difference. So as a DevOps practitioner, now you can define everything in one place, and you just kubectl apply, and things are managed. There's separation of concern. From an operational lifecycle perspective, if somebody goes in and fat finger deletes spanner, it magically comes back up again. Like, how cool is that? So from a DevOps engineer perspective, if you're considering, thinking about where DevOps is going to be in a couple of years, we believe that being all in on Kubernetes, being all in on KRM is the right thing to do.
Cool. So in terms of, one of the questions somebody asked me to ask is, and this may be, I'll start with Lightbend and everybody else's, because most of you have written an operator in whatever framework or whatever style of thing. But why are operators so hard to build? I know you've had some experience at Lightbend building yours. Are they hard, or and is it worth it from Lightbend's perspective to have built an operator?
I think so. Operators are a pattern. They're not. It's not like a framework that guides your hand. So you've got to. There's first, I think, a mental leap that you need to make to understand what the pattern is at an abstract level, and then to connect that with how that's actually going to be useful for you. But I started a new operator the other day just using Operator SDK, and it was very easy to get started. So
what are you writing that operator in to start?
So that was Go, okay. But I've also written operators in Scala. So, yeah.
So does that mean we now need to write an SDK for Scala, or
Yeah.
Yep.
Why not?
Why not? All right. I got a request for a Java one recently, so I'm like, okay, great. So there are some Java ones too. So, and there's someone sent me a link to a Python kit just yesterday. So there's a lot of work that's going on, creating the scaffolding that you need to create an operator from whatever language or tooling that you like. So I know Andre. I'll admit it, I'm at Red Hat, he's at IBM. We now work together, sort of, at least on Slack. And IBM has a long history using Helm, and thousands of Helm charts all across that. And I'm wondering, as you see the operators evolving, how the Helm side of things and the operators side of things come together, and how those patterns work, and where you see that going.
Yeah, you're right. I mean, like I said earlier, we've been doing this for, I'd say, about 3 years now, this containerization of our software. And one of the technology decisions we had to make is, how do we automate this? How do we lay down the resources into Kubernetes? And we chose Helm. And so we kind of, created all these charts, and we now have, like you said, we have, I don't know if it's thousands, but we have hundreds of them. And that served us very well. But I feel like, so first one challenge is that there seems to be this kind of religious debate about all this, right? There are some people who are saying Helm is dead and Helm is bad, it's not secure, and you need to do operators. But then I'd echo what he just said, just saying you have an operator means nothing, right? Because that doesn't tell you if it's a good operator or if it does anything useful, because it's really just a pattern, right? So I feel like There's a bit of this hype now where everyone throws this name around saying like, I did an operator. I'm like, ooh, then you're cool, right? Because you wrote an operator, without regard to whether it serves any purpose, right? So there is a bit of this religious debate to that, but I feel like we've hit the ceiling, if you will, with Helm in that it's really just doing the initial install for us. Maybe upgrade, and even though upgrade even with Helm has its challenges, right? So now we can do install, right? I think the real value that we need to get, because the question that we get asked all the time is like, why should I run my software in Kubernetes? What's the benefit of that, right? And there's a number of value adds that I gain from it, and one is I have a very efficient, very agile, dynamic operational model that allows me to, put quick updates down there and so forth. So I need something to manage that, and that's where operators play a role. So I feel the value to me for operators comes in kind of the later stages, and that's something that Helm doesn't do for us, right? And so that's why we've decided to kind of transition towards that operator model, away from Helm, if you will, even though that's another discussion that we've had is, if I now create an operator that installs software, then I have, okay, now I have, instead of a Helm chart, now I have an operator. I haven't gained anything, I'm still just installing something, right? So the value doesn't really come until I have these additional stages. And so one thing I really started liking is the maturity model, or I don't know what the official name for it is.
We renamed it because people felt bad
Okay.
that we were calling somebody immature. So it's the capability model now.
The capability model, okay. If you're not familiar with it, you should look it up. It's because I think it's an easy guideline to basically say, okay, I have an operator, what does it do? And there's like the first level says I install, second level is I do upgrades, third level is I do backup restore, fourth and fifth are more going into operational monitoring, logging, auto scaling, those kinds of things. And I keep saying the real value of operators doesn't begin to me until you're at a level 4, because until then you're just repeating what we've been doing for many years, just in a different language, so to speak. So part of the question there to us was maybe we should just leave the Helm charts alone and focus on what we call day 2 operators and kind of try to plug that together. And that's some of the discussions we're having with the SDK team, is that if you have a Helm operator, for example, it's not very easy to add day 2 behavior to that. So we're actually not really using the Helm operator anymore at this point.
Well, don't say that because I love Helm.
There you go.
Yeah, so keep those Helm charts alive. I think there's a really, okay, so I'm the moderator, but I think there's a really strong argument for continuing to build Helm charts because operators aren't used for everything under the sun.
And it depends on who you talk to, right? I mean, you just asked the question about what language do you write things in. We have teams where it's the installer team that's writing this logic, right? And they're good at scripting because that's how they've been writing install logic, right?
Yeah.
They're not necessarily developers. So they would say Go. I don't know Go. I haven't done that before, right? And so them, in a Helm chart, you have the ability to basically write templatized YAML that comes more natural to some of those guys, right? And I'm like, okay, there's nothing wrong with that. We then also have teams who are saying we love Go because it's got a great Kubernetes API support, right? So it's across the entire range.
Cool. Go ahead.
I just want to disagree with something.
No.
So you said that operators aren't useful until you get to the level 4 capability, which I don't know, what is level 4?
Level 4 is deep insights,
Okay.
like deep thoughts. Metrics, alerts, log processing, and workload analysis is embedded into your operator.
Basically things that happen past the initial install.
Yeah. So absolutely, you get a lot of value out of operators there. But previous to that, we see some of our customers. If you've ever changed organisations and you go and you need to deploy stuff, and there's usually some process and some patterns that they've developed around how to deploy stuff, which might be encoded in shell scripts or whatever. What operators gives in those first few levels is I guess a common language. So if this organisation is using operators just to deploy software, and this organisation is using operators to implement some common patterns specific to the organisation, then when you move from one to the other, you've got this common language that things are expressed in, which I think is a lot of value for as far as the more higher level end users implementing operators is concerned.
Go ahead, Sonam.
I like to pick up on something that Andrea said, which is quality of the operator. I think that is going to be super critical as customers start to use it. They start to get to day 2, day 3. They start to actually use those operators inside the operator hub or wherever they are using it. If they find that you are still doing things the old way and there are no advantages of doing it, then there'll be questions that will be asked.
Yeah.
So that's one of the things that that I'm working on with the team, which is like rethinking like how do you really put an operator out which changes that behavior, which makes the day 2, day 3 operation much more easier.
Good. I think the other thing that at KubeCon this week, I think I've been in like a dozen hallway conversations about different toolings and different frameworks and different approaches to things. And I know I have operatorhub.io up here because that's where all of my references are, and I don't do slides. So I know where things are. But there are lots of different approaches to building operators and different frameworks. And going forward, do you see some sort of unification or standardization in the tooling? And is that necessary? Or is that just let 1,000 frameworks bloom and we be a good thing?
Well, since I'm in the operator SDK team, I definitely would say that there's a lot of alignment going on with different projects like KubeBuilder, controller runtime. I think that's completely necessary to get a stable foundation. And once you have a stable foundation that works, people agree on, what excites me is that level above it that uses that foundation. I think then you can really see some exciting tooling going on and frameworks that really, drive operator development and adoption, way bigger than it is today, and supporting multiple languages, things like DSLs and things, so that people aren't having to write, miles of Golang code at a very low level themselves, but, they can base new tooling on these foundational things. So I totally think the aligning of some of these tools and frameworks is a must to push this to the next level.
Just all nods here, yes. And for those of you who don't know, the operator framework, which is in GitHub/operator framework, if you go over to the CNCF's TOC on December 3rd, which is my birthday, everybody, there'll be a TOC meeting, and we are working on getting the operator framework itself donated to the CNCF so that it's out in the community and we can all collaborate on it and extend it as we need to. Not that that is the end-all and be-all of frameworks, but it's coming. So just so you know, it would have come faster, but dates and times being what they are. So one of the things that I wanted to ask, because we have a number of software vendors on here, is are operators just for software vendors? So, and how do you see enterprises taking advantage of operators themselves behind their firewalls? Anybody?
I touched on this before. We have customers that are writing operators behind their firewalls and using them. And it's really about encoding their own specific to their industry vertical or specific to their domain requirements in what needs to be done to deploy and maintain an application. So I also think as a lot of operators today are you have an existing piece of software and you then have an operator that is able to expose its configuration, deployment, maintenance through the Kubernetes API. I think in future we might see more, Kubernetes Native, where applications where it's written to be managed by the Kubernetes API using the operator pattern, and that will extend beyond just vendors writing these things, but organizations writing for their own internal infrastructure.
So the other thing that I'm seeing anecdotally, because it's hard to see people's GitHub repos when they're behind firewalls, is this idea of composite operators. and trying to create baseline operators, say for Kafka or whatever it is, but being able to, so that they're not reinventing the wheel. And I think one of the ways that we can help enterprises is so that they don't write things from scratch, they can take these and compose them. So that's I think, the biggest thing that I've heard from enterprises, that some of them write them from scratch, which is fun, and others are trying to pull multiples. Do you see that as a pattern anywhere in your flurries?
So we see this everywhere, right? There's usually a single piece of software, you can deploy that and manage that using an operator. That again, the value, the added value starts happening when you put that in the context of a larger application. So there's always multiple pieces that need to be orchestrated together. And so I think everywhere we look, we find this pattern of operators, whatever you might want to call that. And I think so that's one of the things I'd love to see the SDK team kind of tackle and have more support for. How do I assemble these things, right? How do I aggregate operators into new operators? And is there some tooling that we can get to make that happen? So I think there's a great need for that.
Yeah. So go ahead. Did you?
I was just going to say, operator, composition, discovery, binding, between operators is a really big topic. I think that's going to be kind of the next frontier of where you start seeing, interoperability and people actually trying to orchestrate operators together to do larger grain tasks. I've heard a lot about that at this conference, and there's a lot of interest there. And I think that's really exciting to see those kinds of talks going on.
Yeah, since you mentioned binding, I mean, that's at the top of my personal list. If someone goes and said, what do we need in operator land? I'm thinking we need standardized support and tool-supported use of bindings between services.
Yeah, and moving those conversations forward as rapidly as we can is really one of my goals. I think the other piece of the puzzle for things like Operator Hub, and whether it's Helm Hub or anything else, is automating the testing and the scanning and the building process for these operators. And we've heard a little bit, I think later today we have another meeting, not hallway meeting, but another session talking about just testing operators to make sure that they have the metadata tags and that. Where do you see that going in the not too distant future, hopefully? Oh, everybody says nothing. So how are you testing at Google? I guess that would be a question for Sonam.
So what we are seeing is that there's definitely a need for that. So when we have conversations with customers, they definitely want to go out, simulate, validate, test, even before something is rolled out. And in the context of DevOps, right, like if you think about the day in the life of a DevOps engineer, if you're trying to push out code, the last thing you want is the thing fails at the very end step. So giving those engineers a tool where they can go ahead and figure out, hey, I'm going to roll this thing out, and it's going to have this impact downstream. I'm going to blow through some quotas. Like that is the level of intelligence that we need to get to. So having this common language enables you to do that, because once you have this in a common language, there are open source tooling out there. There are proprietary tooling that all of us are probably building that are more service towards our customer needs. And it's definitely a need. I don't think that we do this right now really well.
Yeah. So if like speaking from the operatorhub.io stuff, there is some testing, there's some stuff behind the scenes to do that, but it's still a review process and that. And so one of the things that I'm interested in hearing is, how do we build the trust in these portals that we build so that people will actually trust that they can deploy Lightbends or Crunchies or IBMs there. So.
The entire notion over here is like having guardrails and having them well lit, right? And that's how you get trust. When you're driving down the freeway and you see those well lit guardrails, you are in a much better place. So if we think about those developers that are just trying to push out codes, if they don't trust the underlying system, and the underlying system is not smart enough to tell them that, hey, you're going to push this code out and it's going to have this downstream impact, then we have failed them. And I think that's the next step that we need to get to is as people are pushing code out, as people are pushing some of these operators out, like having proactive and reactive systems that help them in their journey.
Yeah. So if anybody's interested in the testing side of this stuff, see me afterwards, because we're going to be working through some of that and building those guardrails. So I'm told we only have 5 minutes left. So what I'd like to do is like give each of you a chance to talk a little bit about where you see operators going in the future. So what is the next thing you need besides more SDKs? Where should we be going next?
I guess from my perspective, it's just making the technology as consumable as you can, so that typical developer can work with this, build applications based on it. I think it's still fairly complex.
Yeah.
I think when you go to write a reconcile function, or if you go to try to perform end-to-end testing on these things today and deploy it, it's still pretty complex. So to me, I think the future is making this really consumable by mainstream developers in a variety of languages. And I think that's the next big challenge. I think in order to pull that off, alignment between some of these open source tools and communities is really going to go a long way. And then I think just having people work on these foundational elements and building up goes a really long way. But to me, that's the future of this, is getting it into mainstream so people, can really consume this and it's easy to use. That's what I think is the next big challenge once the foundational pieces are there.
Sonam?
I would have to agree with that, and I think a lot of this is great. I have these set of resources that behave Kubernetes-like, and that is great, but how to extend it to everything that I own? So if I have legacy applications, or if I have hybrid applications, or if I have other things that I still have to go and do manually, or in some other console, that would be a problem. So making it easily consumable so that I can now write CRDs and operators for almost any application out there, I think that would definitely help the community a lot.
Yeah, what they said. Plus, I think there's still new patterns and patterns maturing every day in Kubernetes. So, yeah, for example, how the status sub-resource works with conditions and things like that. If you create a new operator today, those conditions aren't automatically in your well, there's no way that I'm aware of in any of the SDKs to be able to automatically add support for that. And then, the next level from that, if we start encoding those patterns into the SDKs, is being able to bubble up these conditions through statuses of operators that own each other, and a lot of that higher level, those higher level things that make that will make it really easy to write operators, to write good operators that are really useful. So I think it's a lot more higher level patterns in the SDKs.
Andre? The future. Tell us what it is.
I would say it needs to live up to its hype. There is a lot of hype around operators. I think there's not nearly enough, like when you go out on the internet, there's not enough examples, tutorials, references, best practices, standards, and then tooling. I mean, everything these guys said. I feel like we still need to mature this some more so that people have it easy to build these things. I still believe that the knowledge about all this and how to build good operators is very isolated also within enterprises. There's pockets of people that are interested in this technology, and obviously here everyone is. That's why you're here. But I think it's still not quite at critical mass yet for the rest of the world, and I think that's what we need to push for.
Cool. Well, I think that is the end of our time for today. I want to thank all of our panelists for coming and Alexander for hosting. And if you guys are interested, how many of you have built an operator? All right, take your hand down if that operator is not in Operator Hub yet. Oh, a C, okay. So come see me afterwards and let me know what it is, what we need to do to help you get it in so people can discover your operators and find them. So go forth, enjoy the last day of Kubernetes, KubeCon, and please keep building those operators and giving us feedback. So thank you very much, all.